Welcome and thank you very much everyone watching this video. In this video I'm going to show you how to run a binary logistic regression model in SPSS. SPSS is a statistical package for social science, and we use it for analyzing the data that we collected for our research purpose. And I have sample data here. Let me open it and show you the procedure of how to run a binary logistic regression model in this software. My SPSS software version is SPSS 21, and here is my data. Okay, it is a food security, it is a data that was collected from households in rural areas, and it is collected on the food security status, gender of the household's participation in non-farm activities, household's access to credit services, the family size, okay, or the household size of the rural households, and this is the variable livestock, and the data in this variable is regarding whether the household owned or not the livestock units in their disposal. And those are 1, 2, 3, 4, 5, 6. We have 6 variables. And binary logistic regression model, the functional form of binary logistic regression model is it has one dependent variable and more than one or more than one independent variables. In our case, food security will be the dependent variable, and the rest, gender of the household's head, the household's participation in non-farm activities, the household's access to credit, family size, livestock unit, ownership of livestock. Those 5 variables will be independent variables. Therefore, our interest is whether household's food security can be predicted from these 5 independent variables. Okay, and the binary logistic regression model. What makes a model a binary logistic regression model is the nature of the dependent variable. In a sense, the dependent variable should be a categorical dependent variable, which in our case is true. Food security, the dependent variable is categorical variable, wherein household's food security is designated as here in the value. We can see food security. Food security is labeled as food insecure and food secure. Therefore, the variable is categorical. Categorical in a sense, there are 2 groups. There are 2 categories in the variable. The first category is food insecure, and the second category is food insecure. Therefore, our variable is a categorical variable with 2 categories. Therefore, the number of the categories 2 makes it a binary. Okay, a binary dependent variable, and binary logistic regression model or binomial logistic regression model is only run on a dependent variable that is categorical and that has categories that are limited to 2. Okay, 2 in number. And then the independent variables. The independent variable can be a 1 or more than 1, but mind you, it is only in experimental research that only one variable or a single variable can be tolerated in running binary logistic regression model. But in social science and business and other field of studies, it is preferable to have independent variables more than one independent variables. And let me show you how to run the model. And in the SPSS menu, go to Analyze. Then, since we are running a regression, go to Regression, and there are many regression options: automatic linear modeling, linear curve estimation, partial least squares, and binary logistic regression. Okay, let us go for binary logistic regression. And here the dependent variables dialog comes out here, and then the override dialog comes out here. The override means independent variables. Okay, override means independent variables. Therefore, the dependent variable is food security. Therefore, we have to move it to let us display the variable names. Food security. Let us move it to the dependent variable dialog. Then gender. Gender is override. Move it to the override. And the non-farm household participation in the non-farm activities is another override. Credit access is another override, and the family size is another independent variable, and livestock ownership is another independent variable. Therefore we have 5 independent variables. Then the next is let us go to the option which says categorical. We click on it, and here what we have to do is we have to select only the categorical variables and the categorical independent variables and move it to the categorical override. Override can be scale variable, or a category can be when we were entering. Okay, look here, let me show you. When we were entering the variables into covariates, we entered both categorical independent variables and scale independent variables, or continuous independent variables. Gender is categorical. Okay, there are 2 categories, male and female, in the gender variable. Household's participation in non-farm activities is categorical. The household responded yes, okay, when it participates in non-farm activities, and otherwise no. Okay, therefore it is a categorical variable. Credit access, the household has responded yes if it has accessed, otherwise no. Livestock ownership, the household will or the household has answered because we have already collected the data. The household has answered yes if it owns livestock, otherwise no. Therefore they are categorical. Okay, they are categorical. But family size, it is expressed in terms of number 2, 3, 4, 5. Then it is continuous variable. Okay, it is continuous variable. And while we were entering this independent variables into the override dialog, then we entered both the categorical and the scale variables together, or continuous variables together. Here in the categorical option, what we do is we select only categorical variables into the categorical overrides. Therefore what we have to do is gender, non-farm, credit access, livestock, we move to the we move them to categorical overrides. And here contrast, SPSS by default take the last category as a reference group. Okay, the last category as a reference category. In a sense, for example, if we said in our case, we said that credit access, a household accessed credit, a household that responded yes for credit access. Yes, the response yes is represented by 1, and the response no is represented by 0. Then to start counting 0, 1. Therefore the last is 1. When we are interpreting results of the binary logistic regression model, we then take the last category as a reference category. We say households that do not access credit in comparison to households that accessed credit. Okay, therefore the last response 1, okay, 0, 1, the response that is represented by 1, which is yes, should be used as a reference category in interpreting the we will see in another video that will be about the interpretation of the result of binary logistic regression model. Now let us proceed of how to run it, and then we say continue. Then let us go to the options, and okay, has more let me show goodness fit, and we can also go for a confidence interval. Okay, at each step that is good, and then we can say continue. Okay, the probability of stepwise is 0.05 between 0.1. Then let us say continue, and then save. This is we can also select from here, but let us skip, and then let us say okay. Then it will generate a result. Okay. Many tables SPSS generate for us, but we have to focus on only on few numbers. Either the block result is, and we have to skip them, and we start from block 1. Okay, we skip the outputs of block 0, and we have to come to the block 1 tables, and here the omnibus test of model specification, model summary table, and Hosmer and the Lemschau test, and this contingency table, skip it. Classification table should be considered in interpretation, and the variables in the equation is a major is a table. Okay, is a necessary table. It's a quite necessary table that holds the result of the model. Let me highlight, let me a little bit explain a little bit each of those tables. Okay, I will prepare another video that will specifically focus on interpreting the results of the binary logistic regression model, but for today let me tell you a little bit about the tables. Omnibus test of a model coefficient is tell us about the model. Okay, it tells about the model, whether the model is significant or not. Whether the model is significant or not. In a sense, there are two models. It compares a model with independent variable with a model that is without independent variable. The software assumes and takes two models. A model, it assumes a model without independent variable and a model with independent variable. We entered 5 independent variables, and then it assumes that what if the model has no independent variables, and then it compares the two. And we have to see the last row of this table, a model, and chi-square 21.8, and the degree of freedom is 5, and the significance or the p-value is 0.001. It means that when the model is significant, okay, when the model with independent variables is significant, because the model is fit. The model that constitutes independent variables in comparison to the zero model or a base model is significant. Therefore, the overall fit of the model is significant. Let us come to the model summary table, and in the model summary table, Cox and Snell R square or Nagelgerge R square, just two statistics tells us the same thing that R square tells us in the linear regression model. In the multiple linear regression model, R square tells us about how the independent variables predict the dependent variable. The variation in the dependent variable that is due to the independent here, the Cox and the Snell R square and the Nagelgerge R squares are very small. Okay, and since our data is just a sample data to show you the procedure to run binary logistic regression model, it doesn't matter. But Cox and Snell R square and Nagelgerge R square are the statistics that tell us the variation in the independent the extent of the variation in the independent variable that is due to the variation in the variation in the dependent variable that is due to the variation in the independent variables. Therefore, the greater the number, okay, the greater the proportion, the percentage, it is good. Okay, it's good. But here it is very simple, and don't care because we don't care because our data is just a simple. It's just a sample data. And here Hosmer and the Lemshow data is it tells us the model fit, okay, the goodness fit of the model. The goodness of fit means how the data, the model explains the data, how the model describes the data, how the model represents the data. Okay, and this significance level should be greater than 0.1. Okay, most of the time it is, it is around 1.3, 1.5. But if it is greater, no problem. Okay, if it is 0.01, 0.02, 0.05, then it means that the data doesn't represent or describe the model doesn't describe represent the data fairly. Okay, therefore the significance level, you have to look here under here, significance or the p-value should be greater than 10%. Okay, this contingency table for Hosmer and the Lemshow test skip. And the classification table tells us overall the prediction performance of the model. Okay, the model predicted 55% of the variation in the dependent variable. This is a little bit small. This is a little prediction, and no, it doesn't matter because we are just learning. Okay, it is a sample data. Okay, it is a sample data, and no matter. But the point is that what the overall percentage of the classification table tells us is the prediction performance of the model. Okay, what there is observed the observed data and the observed result and the predicted result, then overall how it has predicted the dependent variable, how how percentage, how much percentage of the dependent variable is predicted by the model is given in the classification table, and higher the percentage, it's good. This is the main table. Okay, variable injection is the main table, and in this table there is a confidence interval, there is exponential statistics, there is a p-value, and there is beta standardized beta coefficient. This is a coefficient. Okay, the coefficient of the regression model, the coefficient of the variables, and we have to look here under this p-value 0.02, 0.01, 0.00. Those variables are we included 5 variables: gender, non-farm, credit, family size, and livestock. And here is a constant, the zero model. If this variable is all become 0, then the value of the dependent variable will be equal to the constant, and it generated a result for the constant too. But our interest is to look at the independent variables, and the independent variables p-value is here significant because it is less than the significance level 0.05 in our case, and 0.014, 0.007. Thus are the three independent variables that statistically significantly predicted the dependent variable, which is the food security of the household. Therefore, our interpretation will be male households compared to the female households more food secure, and it is like that. And household is not participating in non-farm activities are less likely to be food secure. And the difference is when you are interpreting the scale variable or a continuous variable, and this is a family size, which is a scale variable or a continuous variable. In this variable, when we interpret, we say a unit increase in, a member increase in a family size of the household is more likely to be food secure. And I said, I promised to you that I will prepare a video that will focus on how to interpret the continuous variables and the categorical variables in binary logistic regression model. For today, this is enough.